Good morning student, myself Dr. Ibha Rani. In this video, I will be discussing about the techniques of capital budgeting. So we have different statistical techniques are there, conventional techniques are there and other techniques are there to evaluate the risk through the capital budgeting process in any investment or in any proposals. So in this video, I will be discussing about the standard deviation or coefficient of variation proposals. So here it involves standard deviation. First we will understand what do you mean by standard deviation. It is also known as the root mean deviation from the mean value. It is the variance which will be the root of standard deviation, and we will understand the coefficient of variations. So it involves evaluating the uncertainty associated with any investment or any project by measuring. How you will be evaluate the uncertainty? Through the measures of dispersion, as these statistical tools are considered as one of the tools through which you can evaluate the dispersion or variability of possible outcomes or variations in the data from the mean values. So it is a tools through which you can measure the dispersion or deviation of a data set relative to its mean. That's why it is also known as root mean square deviation or RMS deviation. It is calculated as, if it is variance is there, it is calculated as square root of variance. By calculating the standard deviation in capital budgeting, we can measure in each case the extent of the variation from the mean flows, mean cash flows. First we will be calculating, after that we will be calculating the standard deviation, and we will be calculating the coefficient of variations. If the value of the standard deviation is higher is the risk associated in that particular project. If here, so we can look into the different project through the standard deviation value or the coefficient of variation. So absolute measure of dispersion is standard deviation, and relative measure of standard deviation is coefficient of variation. It is considered as CV. It is in short form, it is known as the CV value or standard deviation value. It is a statistical measure of the dispersion of data points around the mean. In capital budgeting process, the coefficient of variations allows the investors or finance manager to determine how much volatility or risk is assumed in comparison to the amount of return expected from that particular investment. A low ratio suggests a more favorable trade-off between risk and return. So here CV or standard deviation basically talks about how the volatile is risk, how the variations in the return you will be having. So low CV, if you are looking for the standard return or not much variation, low CV will be considered for that for particular project. So here it is the calculation. This is the process through which the coefficient of variations will be calculated. First you need to calculate the arithmetic mean of the project by the expected cash inflows. So here first we will be looking into the average cash inflows, which is known as the expected cash inflows, which will be cash inflows should be multiplied by the probability. Means probability, the chances that 10% return you will be getting in future, 20% return you will be getting in future, that is the probability, which will be x into f. After that, standard deviation will be calculated. First we have calculated the expected cash inflows, which will be the multiplication of cash inflows and the probability. Second step, we can calculate the standard deviation by the formula. It will be the frequency should be multiplied by x minus x average square. Here frequency will be the probability, whatever they have given the probability in the questions, that should be multiplied by the cash inflows minus the expected cash inflows ka square. And the standard deviation formula is standard deviation divided by mean multiplied by 100. In the cash inflows case, it will be mean will be your expected cash inflows. So coefficient of variation formula is standard deviation divided by mean should be multiplied by 100. And last step, to accept or reject the project based on this statistical measures, it can be standard deviation or mostly we will be using the coefficient of variations. So coefficient variations measure the riskiness. More CV means more risky project. So if you are not looking much for the risky project, so the low CV need to be considered. This is the calculation of CV and standard deviation. This is the proper format you need to follow when you are solving any problems based on the standard deviation or coefficient of variation. Here cash inflow should be considered as X value, probability I have considered as F. So mean will be summation of F into X. Your probability should be multiplied by your cash inflows, and adding all those values you will be getting the mean values of cash inflows. And then standard deviation formula will be standard summation of F is here, probability should be multiplied by X minus X average ka square, and coefficient of variation formula is mean divided standard deviation divided by mean should be multiplied by 100. So in the questions, in the any problems, if they have given you X value will be considering cash inflows in that. Probability, whatever they have given in the questions, that will be the F I need to consider. So mean will be multiplying the cash inflows with your probability, you will be getting the mean value. After adding all those value, you will be getting the summation of F into X. Then cash inflows minus mean means X value should be subtracted by this mean value. So X minus X average, multiply this square of this value, and multiply this probability, you will be getting the standard deviation formula. We will understand this standard deviation and coefficient of variation with this example. So here they have given in these questions, from the following information ascertain which project is more risky on the basis of standard deviation, and also calculate CV value or coefficient of variation. So you need to consider which project is more risky. They have given the project A, and there are two projects are there, project A and project B, and their cash flows are they have given, and the different probabilities in the both project they have given you. So now we'll start with this. Here the cash flows they have given here in for the project A. First we will be look into the project A, then we will consider the project B. Mean value, standard, basically three formulas we will be looking whenever standard deviation questions will be coming. Here first we will be considering the mean, then second is standard deviation, and third we will be taking that CV value. Here CV value we have considered. For both the project we will be considering, after that we will be comparing both as per the mean, standard deviation and coefficient of variation. For the project A, these are the cash flow and this is the probability. First we will be calculating the mean or expected return, mean values of the cash inflows. So we will multiply this cash flows with this probability, we got this F into X, and adding all those value we got it the 6200. So the expected cash inflows for the project A, that is the mean value, is 6200. Now this 6200 should be multiplied by should be subtracted with the cash flows. Here 2000 is there, 4000 is there, so here I have subtracted 2000 minus 6000 is minus 4200, 4000 minus 6000, like this I have calculated this value. After that we have multiplied x square of this value, means 4200 should be multiplied by 4200. Then this value should be multiplied with your probabilities, so this we got it. So summation of fx square, we have calculated this value. So mean is the summation of fx by n. Whenever the probabilities questions will be coming, always the n value will be 1 or it will be 100%, because it is the probability, the maximum chances you will be getting it. So this will be 6200. Mean we have calculated. Standard deviation is 2600. We have calculated. Then CV will be standard deviation divided by mean. It should be multiplied by 100. So that always CV value will be coming under the percentage form. So here standard deviation is 2600 we have calculated. Mean is 6200, should be multiplied by 100. So it should be CV becomes 41.93%. We have calculated. Mean is 6200, standard deviation is 2600, and CV is 41.93%. Now we will be calculating for the project B. The same process we will be follow. The mean first we will be calculating, subtract these cash flows with the mean values. Here mean or mean cash inflows is 6000. We have calculated standard deviation as 2191 and CV value with the same formula. How we have calculated for the project is exactly the same process should be followed for the project B as well. So we have calculated. So now we will conclude. So for the project A, we got it the mean cash inflow is 6200 and the project B is 6000. Standard deviation for project is 2600 is 2191. CV for the project A is 41.93 and for project B. So here which project is more risky, they have asked you. So more risky will be when variations will be more. Variations will be more means when coefficient of variation CV value is more, those project will be considered as more risky. So here as per this, CV of the project A is more compared to project B. So project A is more risky. So I hope you understood with the concept of standard deviation and coefficient of variations and how to look into the project with statistical techniques. So thank you. Bye bye.